Okay, so we need to understand what is cookies and what is session-based authentication and how they're different from each other. So we are talking about both of these. Session we have already covered. Cookies also we have covered, right? So what is the cookies? Cookies are like small data stored at the client side on the browser sent by server. Sessions are server side only, and we are storing the user data. Cookies are sent by server, stored on the browser, and server sessions are stored inside a server's memory. And you need to have a cache like redis. Use case when you want to store a session ID or tokens in the cookies. Here in the sessions we store the actual user information. So this is just a comparison I'm showing, like what is cookies and what is session-based authentication. So in cookie-based authentication, server sends the cookies data to the client. Okay, that can contain a session ID, token. Client stores it and sends it back with every request. I mean, this is the browser behavior, that cookies are persisted on same domain and they send the cookies back to the server. Server identify, validate. These are very easy to set up, works with every backend and can be stateless with the token. Cons, you need to take care of the security of the cookies, that no third-party application should be able to access your cookies. Session-based authentication, it creates a session at the server side and you need to store that session using some kind of a persistent mode like Redis database or something. Client sends the session ID in form of cookies only. I mean, indirectly this is also using cookies. Server send a session that is managed through cookies, and in the consecutive request you are going to send the cookies back to server, where server will validate your session. So scenarios, where should we use what, right? So when you are using just a single page application, you can just use session based authentication. Mobile application, then you can use a token based authentication, or a single page with the backend, then you can also use cookie based with the session ID or token, right? So these are like very much differences. Further we will also talk about plain token based authentication. That is also has its own case when you want to have a stateless authentication, that server sends the token, now client receives the token, now the token is valid till the expiry of the token, right? So in the next request you will be sending the token in the authorization header, and that token is valid till the expiry of that token. So if somebody copies the token, he can access your APIs. So let's talk about the actual implementation now. Our application is already up and running. You can see I just did npm run start and our application is running on port 3000, right? Now what we are going to build, let's little bit talk about it. We are going to build a simple login request. So we'll write a controller, auth module, auth controller, auth service, where we will validate the user credentials. If user is valid, we will send a token, okay, JWT token with the payload, something like user ID and a username, sends with the JWT using response.set cookies, right? And those cookies are HTTP only. That means the client cannot access them, manipulate them. Client stores the cookies in the client side cookies, and then on the consecutive request like profile, post data, we will be writing a middleware that will extract the cookies from request.cookies.auth token. Okay, once you get the cookies like auth token, you will validate the JWT token expiration, attach and decode the request user object to the request. So we will be implementing auth guard, local strategy, JSON web token. We will be using the passport module. Passport provide all those features, and whenever you do logout, we will return cookies empty, or you can just clear out all the cookies from the server side, set the expiry 0. That means all the cookies will be reset, and when they will be sent to the server, they already expired. Security considerations, will be using the HTTP only. Cookies are secure for production. Token will have an expiry, okay, and we are going to just write auth controller, auth module, auth service, and this JWT strategies like JWT auth guard, JWT strategy, and we are going to write a user controller because we will also want user to sign up to our system so that later he can log in. Okay, so let's get started. Hi everyone and welcome back. So we are talking about cookie-based authentication and we are doing the code setup. So there will be few things which will still be the same, like the database. Database we can copy from the existing session-based authentication. If you look at the database code, what it contains, it is just a module which is initializing the Postgres database connection. Right, this is the root module, and how to initialize it? It is just using the same asynchronous initialization of a typeorm module where you are passing the configuration options, which contains the database URL, which looks something like this. Type is Postgres and SSL. Okay, so what I will do is I will copy and paste this thing. Okay, what it is, it contains the database configuration, and how to initialize it? In the main.ts we will initialize it. So inside app module we are doing db module.forRoot and passing all the entities. Same thing we will do. db module.forRoot, and I will copy this code in the source app module. Okay, inside import, because this is the external module we are importing. db module we can import. User entity we are going to create. So once we have the entities, we will pass it here. So what this db module is doing? db module is actually providing us the database connection. We are calling db module.forRoot for initializing the connection, which is calling forRoot async. We are passing config module. Config module is nothing but providing the database connection URL. So we also need to have a config service somewhere set up. So let's go to this project. How we were managing the config, that we can copy from here. So app module. So we are using just a simple NestJS config module. forRoot, what it is doing is it is capturing everything from the from the .env file and giving us everything inside a config service. So app module. Let's see, do we have a config module? We can import it. Yes. And I will try to import things which are needed here, like typeorm, Postgres, NestJS typeorm, all these modules. I have fixed the dependencies, and now you can see I can do npm run build. Package.json error. Let's see what it is. What is the error here? I don't see there is any error. Let's see the project again. Okay, I'm not in the right directory. Sorry for that. I need to go to the NestJS setup, npm run build. So now I'm in the right directory and it is working fine. So what I did, config module.forRoot, db module. So db module is same thing. It is initializing asynchronously our typeorm module. It needs env file to get the database URL, and we already have a Postgres running. So what I will do is I will copy both these files. So what this env contains, the database URL. We don't need redis, we don't need session, but we need database something like this. So we need to check our database is running on this port or not. Docker compose override file and 5433. Okay, things looks fine. I can even start this application. npm run start will start this application. Let's see what we get. Yes, and my application is started. Config module initialized, typeorm module initialized. That means our database module setup is correct. I mean, this is what I copied, and every project will need this config database module because I'm using typeorm. Here you can change the type to Postgres, MySQL, and initialize the different type of connections. I mean, here forRoot, Here you can check, okay, database type is Postgres, return this kind of a configuration. Here we are passing all the entities, synchronization true. That means whenever typeorm starts, it synchronizes the entities into the database tables. Logging true false, it will show you the SQL on the console. SSL is disabled for the development. So this is a simple database setup. Now we will start adding the more libraries. Currently our project contains not many things. I just added a couple of things like NestJS typeorm, Prisma we don't need, because Postgres we need, Redis we don't need. I will remove those things which we don't need. Passport and passport strategies we need, so I'm just keeping that dependency. NestJS GWT, passport, typeorm, all these configurations we have. So let's start adding the user module and the auth module with the controller and their services. So now we have database setup. Now we just need to do what? Inside domain, you can start creating user entity, pass the reference of user entity here, so it will bootstrap that. So let's try to do one simple thing. We will try to copy the user entities from here and see the magic. So here I had a user entity. So let's copy this user entity here and try to pass the reference. So just try to show you how all these things are connected. So I will import this thing and I will start the application again. And you can see it will try to synchronize the user table. You can see user table doesn't exist earlier. Now it sees the okay, user entity has been added. I need to load this. So it has created this table. You can see the SQL create user default with these attributes. Okay, we'll try to define our user table in nicer way. So let's work on that. Hi everyone, so let's add our user entity all required attributes. It's not like just we need to store the email and password. There are a couple of more attributes which we are storing. So all these things we are importing from the user entity, and now we will add, okay, this is entity. So there is a syntax which we follow to create entities in the typeorm. So the ID is auto-generated column, then all these columns. So we are specifying type, length, select, unique. Email should be unique, varchar, length is minimum. I mean, you can just, you do not specify the length, then it will take more. Password, last name, first name, email, password, reset password, we can store the address. So all these attributes we are storing inside a user entity. And when I save this and when I start our application, so typeorm will check, okay, you have updated the entities. So it will update the database table. So we have a refresh token, first name, name, all these respective attributes added here. So this is our user entity, and now what we will do is we'll go to the terminal and here I will just do npm run start. So I have updated a new entity. It should be able to load it, and here you can see it has updated things that we can see in the query. Table schema, and it should have some update query somewhere. Let me just see, because it has loaded the typeorm, app module, domain module.for root. We will also check the database. So we are using Postgres. You can just use the Postgres tool or Postgres admin to see the table structure of our database. So copy our connection URL, which is this, right? Copy this, and you can use this connection URL to connect to Postgres. So this is the user entity inside a user module. Let me fix this thing. What's the name? It's user entity. Let's replace it. Now I will start the application again. Okay, it did like create table users, and we can check this here. Okay, the table name is different. That's the typo. Earlier the table was user, so we can just delete this table. We can just use users table, and this is the structure of this particular table. We are storing refresh token, first name, last name, email, password, right? It just I changed the entity name, right? Earlier it was user, now it is users. So you see the power of typeorm. It checks, okay, you have a new table, I will create a new one. Or if you are adding a new column, let's say first name, last name, or you can say family name or something like. I will start the application again. It checks, okay, you have added a new column. So you can see it has added alter table users add family name. So this is how typeorm works, and all the relationships one-to-one, one-to-many, many-to-many. Currently we have only one table to play with. This is the user entity. Now what we will do is we will write a user controller which will allow us to create users. Hi everyone, so let's work on the user controller here. I will do user.controller. What we are going to do in the user controller, just like let's say we should allow user to onboard. We should be storing the password in the bcrypt form. It's just like open sign up where user enter the email, password and the first name. User should be able to enter in our system. So controller is simple. We have already written the controller code many times. It is just a simple, you import all the required things and then write the controller methods by using the basic syntax. Here we define all the routes. We first importing all the things from the NestJS common. These are some Swagger dependencies which makes our controller API methods exposed on the Swagger docs. API bearer auth, API header, API OK response, OK, API internal server response. These are just to add the required messages on top of your each and every APIs. So your APIs feels good, right? All these guards and all we will create, because once user logs in, user should try to access his own profile. There we need all these guards, strategies and all. These are the DTOs which we are going to define. And with user controller, we also need to define a user service, because controller will talk to user service, and user entity we already have. These are a couple of constant, like, okay, every API need to respond with the status code 200, internal server error, another bad request. So these are just a constant message, and this is authorization. Not every message needs authorization header, only the private APIs, and this is the validation pipe. And the controller is users. Now I'm writing user controller. Here you can inject a user service, because user service will have a methods to save the user, validate the user. Now we'll just HTTP status code created, which is 201, type user sign up response DTO. These are the custom Swagger methods which will expose these things on the Swagger docs. Okay. What user created successfully, this is for user creation. What is a API consume, this is the HTTP post, create user. We will pass things inside a body. Okay, and here we are just creating a simple user. Okay, this dot service dot create. So we will just talk about what we are going to add inside a user service, because these things I have written many times, so I'm not duplicating the same syntax here. User entity, user controller. Now further you can add multiple methods. Okay, this is post. What I can do is HTTP status code dot OK. This is user updated or user fetched. This should be the get call. Okay. API OK response, because we are not creating here anything. Once you logged in, you should be able to pass the param. So here it should be param. That we will change. Okay. Fetch user something like this, and we'll just pass param. Okay, and this will be the get, and we will try to populate your user ID inside a session. So you don't need to do, okay, get user by ID. When you say get, it will give your own session, I mean own user information, because there will be the APIs. What they will do is they will give us the required session information. Based on that, we should be able to fetch your profile. So we will be adding all these type of guards that I will do later. But okay, authentication token guard, role guard, that even a particular role is allowed. So these are the things which you will add because this is the private API. Who should be allowed to read the user information? Either I myself or a particular system administrator. And of the access token guard, role guard, they will just help me so that only the protected user who has the access token should be able to read it. So we will talk about these things little later. I'm just commenting these things out for now. But this is just a simple API. Currently it's a public API, but when you add these guards, it will become private API. So this is to get a user, your own user. There can be a user, another API, okay, give me all the users. So let's create another route. This profile is to give you your own profile, okay. Then we can have another route which says, okay, give me all the users from the system, and only system administrator is allowed to do that. So this is where the role guard comes into picture. Okay, if you are a system administrator on HTTP GET, you should be allowed to fetch all the users. But if you're not a system administrator, I don't need a role guard here. I just need activation guard, access token guard. That means you should be passing the authorization header. You should be able to fetch your own profile. Okay, so these kind of logics we will write, and then we will add a user service. In user service, we will just create a user inside our platform.